part below that line. Okay? We're learning today how to partition a directed line segment. Okay? This isn't just any line segment, there's a direction to it. Okay? So a directed line segment has both a length and a direction. Has both a length and a direction. The components of the directed line segment AB is a run and a rise. What do you think the run is of A to B? Notice A came first and tells you the order. A first, going to B. The what? Reverse. Yeah. So the run is the x's, right? The horizontal axis, running sideways, left and right. That's your x-axis. So x2 subtract x1 will tell you how far you run to the right. Because going to the right should be a positive value, right? Going to the left is negative, just like something else. X2 minus x1 should sound familiar in one of my formulas we've known for a few years. How do we find the rise from A to B? Y2 minus Y1. When have we heard things like this before? Y2 minus Y1 and X2 minus X. Slope. Okay? And when slope is going up to the right, you know that's a positive. It's going down, you should be expecting a negative. Okay? Example 1, we have points P and Q here. They're not actually on the coordinate plane, but you can see the coordinates 5, 4, and 9, 6. When moving a directed line segment, pay close attention to the beginning and end points of the line. For example, PQ is something different than QP. They're the same length, they're the same letters, but the order of the letters tells you the direction you're moving. The first one, P to Q, starts at P and runs to Q. So if you could describe, where is P at? What? Okay, I'm actually looking for a descriptive word of where its location is, not 5, 4. Starts with an L's, 4 letters. The left. And then we run to the right, okay? So it runs from left to right. Versus QP starts on Q, so we're starting on what side? The right, and you're moving left. Okay? So you need to be paying attention to the letters, and the order of the letters, because it does tell you. The route from P to Q is a run of, we start on P, and we run to Q, running again. Which axis is horizontal? X-axis. So you're looking at the axis from 5 to 9. What's that run? 4. Does anyone know how mathematically you can find it out? Yep, say hard. Subtract what minus what? No, you can't pause before, don't you have to have the larger number? So it's x2 minus x1. So we'd actually be doing 9 minus 5, which gives us a run of 4 units. And the rise, this is familiar with slope, a right triangle, we rise from 4 to 6. So how can we mathematically find that rise? 6 minus 4, which is 2. This one's easy to just know it's 2, but sometimes you get more complicated ones, and so you need to know how to do it mathematically. Y2 minus Y1. Okay? Now, the reverse though. The route from Q, starting on Q to P, now the order has changed. From Q, I'm going to run over to P. Okay, mathematically, there is a hand who can tell me how to mathematically find that one. Yeah? 5 minus 1? Good. Because That's our second point, right? At any point. 5 minus the 9. So does it make sense that 1 is actually negative? Because we're going left. And going to the left will end into the negative numbers, right? And rise from here to P. So we do it perpendicularly. Creates a nice little right triangle. Tatiana, what would that rise be? Good. 4 minus 6, which is negative 2. Either way, rise over 1, 2 over 4, we have a positive slope, or a negative 2 over negative 4, we have the same positive slope. Still the same positive slope. The slope is right left to right. So with direction, our run units and our rise units could change signs like that. Okay? The same concept they use for slope. We've already talked about that. So let's look at, when dividing a line segment into a given ratio, we need to first determine the number of parts. This is what we're learning today. It's easy to just divide the line segment in half. That's easy, right? We don't have to find midpoints. Okay? But that's so easy if I want you to divide it into thirds or to a ratio 2 to 7. Not as easy. That's what we're learning today. A line segment divided into a ratio. Notice the keyword ratio. 3 to 2. How many parts does a line segment divided into a ratio 3 to 2 have? A line segment divided into ratio 3 to 2. Meaning one side has 3 parts for every 2 parts on the other side. 5. So the ratio, actually you have to add up those two numbers. There are 5 parts in total. For every 3, 1, 2, 3 equal parts of the first part of the segment, it equals 2 equal parts of the second part of the segment. So 3 on the one side, 2 on the next side. But in total, there are 5 parts. So don't be confused and think that there are only 2 parts. That's not the case. There are 5 in total. So line segment example 3, the bottom, a line segment divided into ratio 3 to 5. Can I have fingers in the air? How many parts are in the ratio 3 to 5? Fingers in the air, how many parts are in the ratio 3 to 5? One part has 3 and the other part has 5 units. And in total there would be, Sadie? 8, yep, 8. One part has 3 units, and the other part has an equivalent, like an equal section. 1, 2, 3, 4, 5. And in total there are 8 parts, okay? That comes from the ratio. Flip it over. Okay. Example 4. T is -8. So let's find -8 and put capital T. We're looking one-dimensionally right now. We're going to have a line segment. Actually, we're going to be looking two-dimensionally to partition a segment. For R is at 6, so if I'm positive 6, plot it and put R. We're going to find C so that TC, notice the order of the letters. Where are we starting and where are we ending? Starting at T, ending at C. So that means we're moving directionally to the right. Okay? Is C is -8, R is 6. Find C so that TC is 3/7 of R. 3/7. So let's say this was a ratio, 3 to 7. No. 3/7 is your percentage into the segment, moving from the left to the right. 3/7 of the way over. So we have essentially 4 steps of how you partition these segments. Step 1, if you're given a ratio, change the ratio to a percentage. I had it written better on my little piece of paper. I don't know where it went. Here it is. Write your ratio as a percentage. Make sure the denominator is your total parts. So you have the certain quantity A out of the total that you're moving over. Okay? After you know that, step 2, we're going to find, you know what this little triangle X means? Change of X. Change of X. It's really talking about the length from y2 minus y1 or x2 minus x1. Change of X or the change of y, or both. Step 3. Once you know that change, you're going to multiply the change of X, and or, depending if they're one-dimensionally or two-dimensionally, the change of Y by your percentage you found in number 1. Okay? And then you add that to the starting point. Sometimes the starting point is on the left, sometimes the starting point is on the right. Okay, so first step, let's find the ratio as a percentage. And we're told, find C that TC is 3/7 of TR. What's the ratio? Does that mean we have 10 parts if it's 3/7? Do we have 10 parts? 3 plus 7 is 10? Or do we have 7 parts? We actually have 7. This wasn't the ratio. They already did step 1 for us. So our percentage is 3/7. Step 2. We're going to take that 3/7, well, first we'll find the change of X, and then we'll multiply them together. So the change of X, we start at T, -8, and we go to the right until 6. The change is x2 minus x1, or what's the length of that? 14. So mathematically, though, we do 6 minus -8. Does it actually make 14? Because we go, well, 6 plus 8, 14. Okay, we take 14. Now we're going to times 14 by what? Step 3, multiply the change, which is 14, by the percentage. What's our percentage? 3/7. So we can actually divide 3/7 to find the exact percent, but it's easier to work with in fraction form. Okay, and this actually simplifies. These ones on our worksheet, or notes at least, are so nicely. 14 on top, 7 on bottom. So they both have a common factor. Divide by 7. 14 divided by 7 is 2. 7 divided by 7 is 1. So we get 2 times 3 is 6. Does that mean my plate's going to be on 6? Is this 3/7 of the way over? No. That means starting on our beginning point, we're going to move 6 units. So I have to start at -8, and I have to add that 6 I found, which means I would now be on which point? -2. That's where I should put point C. Okay? And if you want to analyze and make sure you actually put it in the right place, 3/7 is the same as 6/14, right? And it's times the 3 by 2 and times the 7 by 2. Because I knew this was 14 units long. So if I take every 2, how many units of 2 do I have until I reach C? 3. And in total, how many units of 2 are there? 7. So we've gone 3 of the 7 over to the right. So we partitioned it in the right spot. The ratio, 3, well, we don't have a ratio, but 3/7. That's the way over. Okay? Let's look at the next one. B is at 7. So find 7 and put capital B. is at negative 3. Find negative 3 and put capital T. Please make sure you write this down. Find x so that the direct line segment is B to T. Where would we start? We start at B, which means we're moving left. Our starting place is B, we're going to move left to T. And it's partitioned by the ratio 3 to 2. Okay, I'm going to work for this one over here. First step, write the ratio of the percentage. 3 to 2 is not a percentage of the way over. Well, how many parts are there? 5. And those are going to move first. 3. We're going to first from B, we're going to move to the left 3 units, and then that would be the perfect spot to have exactly 2 units remaining until the endpoint T. So for step 1, we're going to go 3 of 5. Is this today? We have a stage test today. I wish people count me. Crap. Most of you are going for the filter or the hard work too. That was not good. Oh. I don't have computers at home because I can't get into the lab again. This is the only time I can get into the lab. Okay? So we take 3/5. And the 5 comes from 3 plus 2 is 5. Step 2, find the change from ending to starting. So we actually end over here at negative 3, subtract 7. Why is it negative? Because we're going to the left. So the run is to the left, so it's negative. Now we take that negative 10 and we times by our 3/5. We're going to move 3 parts of the total 5 across. Notice this one's a nice one. You can see it cancel. I hope negative 10 on top, 5 on bottom. Can we say how many 5s are negative 10? Positive? Negative 2. How many 5s are in 5? 1. So we're left with negative 6. Does that mean my point in the middle of T to B is over here at negative 6? No. It means I take my beginning point and I add them together. 7 plus the negative 6, which is the same thing as 7 minus 6, leaves me at 1. You have a problem? 3/5 comes from our ratio. First, we're going to move 3 units out of the total of 5. And then there should be 2 units remaining after it. And it works because, let's see, this is letter S. We move 1, 2, 3 units, and there were 1, 2 exactly remaining. So we partition it with a ratio of 3 to 2. So 3 units, we move 3 units, and there's 2 units remaining. And this time we're moving to the left. Okay, we're going to try a 2-dimensional one. Look. Not always. You try to get your length. Remember how this one? I had 3 7s, but I knew I had 14 units. I just try to make that denominator match, so I multiply by 2. Okay? 2-dimensional. You do the exact same thing, but you do it once for the x's, once for the y's. Okay, find the point Z. And there's a typo. Later here it says point P. We should keep that the same letter. It should be point Z. That's a typo. So change that to Z. Okay, from segment A to B, we tell you the order. So came out where they're starting. We start on B or we start on A. So you start on A, and then you go to the right, to B. By the ratio of 1 to 3, which means we're only going to go 1 part, and then there should be equal 3 parts remaining, right? We're going to go a little bit, so first we should have a shorter segment, and then we should have a longer segment once we partition it. Determine the number of parts. Step 1. Can I figure in the air how many parts is this going to be divided into equally by the ratio 1 to 3? Good. 4. 1 and 3 parts make 4. So so we need this as a fraction. Notice the first number, we have to only go 1 unit out of the 4. So we can find out what we do next. Find the change of x. We're going to start here with the runs, just focusing on x. So we need to know the coordinates of these points. Okay, Adam, what is the coordinates of point A? Good, and which one of those is actually the x? A1. So let's just focus on the x for a minute. Okay, Loretta, what are the coordinates of point B? And which one's the x? Good. Okay, so x2 minus x1, meaning the ending x minus the beginning x. Which one's the ending x? 7. Minus the beginning x. -1. So we actually have 7 minus a negative. Well, 7 plus 1 should be 8. The horizontal distance between those 2 points is 8. Let's go down to step 3. Just swim with the x's and we'll go back and catch the y's. So we know x has a horizontal run of 8. So we times by what? 1/4. Because we're going to move 1 out of the 4 parts. This one's nice again. Tyler, does anything simplify or cancel? So 2 and 1. So we get 2. The 2's our answer. So then tell me what we do with that 2. Add it to what? Which x? The beginning x. We started on x was -1. So we take our 2 and we add -1. We can add it in any order because we're changing the property. So we get 1. So we have the first coordinate. B's first coordinate is 1, comma. We'll find the y here secondly. Time. Put that away, please. So now let's go back through and look at the run. Okay, sorry, the rise. y2 minus y1. The beginning y, subtract. Actually, no, the ending y, y2, huh? The ending y subtract the beginning y. And then what's the ending y? But the y? This is the ending, because we're starting at A and we end on B. So we have -3, subtract the beginning. This is y2 minus y1. Okay, the Pico, what's the beginning y? 9. So -3 minus 9 means -12. Why is it negative? Because the segment from left to right is going down. Okay, so we take that -12 and we times by something to find out how far into the segment we need to go. Times by our percentage, 1/4, 25% of the way in, which -12/4, -3. We need to add it to the starting y. So do you know what's the starting y position? 9. Good. So -3 plus 9, which is the same thing as 9 minus 3. 6. Actually, are you writing this stuff down? 1, comma 6. Let's see what that is on our graph. 1, comma 6. Oh! Is that actually on the graph? That's a good sign. If it's not on the graph, you've definitely done it wrong. Okay? And look at the new staircases. From here to here, we went down 3, right 2. Okay? I'm going to keep that going. Down 3, right 2. Down 3, right 2. Down 3, right 2. How many orange staircases were there? 1. How many black? 3. 1 to 3. We correctly partitioned it. So this is an example that I know of one that's not a 2, right? I just matched the staircase. I kept that pattern going. Down 3, right 2, down 3, right 2, and we got in the end is perfectly on the end point. So we did in fact partition it with the ratio 1 to 3. Okay, that's where we're going to stop on this one today. Got a lot of stuff, including calculators. We're going to go into the lab.